All right, let's talk about a problem I know you've run into. You do everything right, you set up your VLANs to keep the network nice and organized, but now your departments are stuck on different floors, totally isolated from each other. Well, today we're building the bridge. We are diving deep into network trunking.
So, picture this. You got your network perfectly segmented. Sales is on VLAN 10, engineering is on VLAN 20, but half the sales team is on the first floor, plugged into one switch, and the other half is upstairs, plugged into a completely different switch. They might as well be on different planets. Even though they're in the same VLAN, they're on these separate physical islands and they just can't talk. So how do we solve this? How do we build that bridge so that VLAN 10 on the first switch can talk to VLAN 10 on the second? And how do we do it for all of our VLANs without just running a crazy, messy spiderweb of cables for every single one? Well, the solution is actually incredibly elegant, and it's a super powerful concept called a trunk. This is the special connection that's going to bridge that great VLAN divide. Think of it like this. A regular switchboard, that's like a single-lane country road. It's built for just one type of traffic. A trunk port, though, oh, that's a multi-lane superhighway. It's a single physical cable, a single port that is specifically engineered to carry traffic for many, many different VLANs all at the same time. And this slide right here breaks it down perfectly. An access port is for one device, your PC, a printer, and it lives in one and only one VLAN. A trunk port is the VIP connection between your switches. It's the express lane that by default carries the traffic for all your VLANs. Getting this difference is absolutely the key to making your network work the way you want it to. Okay, so if we have all this traffic, sales, engineering, marketing, all flying down the same superhighway at once, how does the switch on the other end not just see a giant traffic jam? How does it know which car is supposed to go to which department? Well, it needs a sorting system, and that system has a name. .1Q. .1Q is the universal language of trunking. You can think of it as the network's own internal postal service. As a piece of data gets ready to cross that trunk highway, .1Q adds a special little stamp to it. We call it a tag. And that tag clearly marks exactly which VLAN it belongs to. And this lays out the whole journey perfectly. A PC in the sales department sends some data. The first switch gets it, slaps a VLAN 10 stamp on it, and sends it flying down the trunk. The second switch at the other end catches it, reads the stamp, and says, "Aha, this is for sales." It then removes the stamp, because it's no longer needed, and delivers the data only to the sales team ports on its side. It's so simple, but incredibly effective. And you know what's just amazing about this whole system? The efficiency. This entire brilliant sorting mechanism relies on adding just 4 extra bytes of information to each and every data frame. That tiny little 4-byte tag is all it takes to direct traffic across a huge, sprawling network. It's what ensures every single packet finds its way to the right home.
Okay, so the tagging system works like a charm for all of our known VLAN traffic. But what about mystery mail? What happens when a frame shows up at the trunk port with no tag at all? The switch has to have a plan for this too.
And this is a really, really important question, because how the network handles this has some major implications for how things work, and more importantly, for your network's security. There has to be a default plan for this mystery mail. And that plan is called the native VLAN. You can think of it as the network's general delivery mailbox or its lost and found department. Any traffic that shows up on a trunk port without one of those .1Q tags is just immediately assumed to belong to whatever VLAN you've designated as the native VLAN. Now, out of the box, pretty much every switch on the planet uses VLAN 1 as the native VLAN. And since all of your unused ports also live in VLAN 1 by default, well, you can see how that creates a pretty easy target for bad actors. That's why it is a universal best practice to change the native VLAN to some other unused number. You're essentially creating an isolated dead end for any of that weird untagged traffic. And here it is, the golden rule. The one thing you absolutely cannot forget. For a trunk to work properly, the switches on both ends of that cable must agree on which VLAN is the native VLAN. If they don't match, you're going to get all sorts of unpredictable behavior and weird network errors that are a real headache to track down. All right, so we've got the theory down pat. Now let's get practical. How do we run this whole mailroom system efficiently? And most importantly, how do we keep it secure? First things first,
only send the mail that actually needs to be sent. By default, a trunk just lets traffic from all VLANs go across. But hey, if the switch on the second floor doesn't have a single person from the marketing department plugged into it, why are we flooding it with all of marketing's broadcast traffic? Manually pruning the allowed VLAN list is just good housekeeping. It keeps unnecessary traffic contained and cuts down on all that network clogging chatter, making everything faster and happier. And second, please do not leave your ports on autopilot. By default, a lot of switches use a protocol that tries to automatically figure out if it should become a trunk. This is a massive security risk. An attacker can actually trick a port into becoming a trunk, which could give them a front row seat to traffic from all of your VLANs. The solution is so simple. Explicitly, manually configure every single port. It's either an access port or it's a trunk port. Never, ever leave it up to chance.
So the big takeaway here is pretty clear. Trunking is absolutely essential for building a scalable network with VLANs, but those default settings, they can be a hidden liability. It's an incredibly powerful tool, but it demands careful, intentional configuration, which really just leaves one question for you to think about. Are you running your network on secure, intentional settings, or are you just exposed by default?